This article describes the implementation of International Civil Aviation Organization airspace classes in the United States of America. For a general discussion of airspace classes, see Airspace class. The United States Airspace Systems classification scheme is to provide maximum pilot flexibility with acceptable levels of risk appropriate to the type of operation and traffic density within that class of airspace. In particular to provide separation and active control in areas of dense or high-speed flight operations. The Albert Roper implementation of International Civil Aviation Organization airspace classes defines classes A through G. The other U.S. implementations are described below. The United States also defines categories of airspace that may overlap with classes of airspace. Classes of airspace are mutually exclusive. Thus, airspace can be Class E, and restricted at the same time, but it cannot be both Class E, and Class B at the same location and at the same time. Note: all airspace classes except Class G require air traffic control clearance for instrument flight rules operations. Airspace classes: in the U.S., airspace is categorized as regulatory and non-regulatory. Within these categories exist controlled and uncontrolled airspace, based on which air traffic control service is provided to IFR flights and some VFR flights. Class F is not used in the U.S. Besides controlled and uncontrolled airspace, other types of airspace include special use, and other airspace. Class A Class A airspace extends from 18,000 feet mean sea level MSL to floor 600 MSL, throughout the United States. Unlike the altitude measurements used in other airspace classes, the FLNNN flight levels used in Class A airspace are pressure altitudes referenced to a standardized altimeter setting of 29.92 inches Hg, and thus the true altitudes depend on local atmospheric pressure variations. Unless otherwise authorized by ATC, all flight operations in Class A airspace must be under ATC control, and must be operating IFR, under a clearance received prior to entry. An example of an exception to IFR-only flight in this airspace is the use of wave windows. These specific airspace blocks may be opened by ATC to allow sailplanes to fly in the lee waves of mountains. Since Class A airspace is normally restricted to instrument flight only, there are no minimum visibility requirements. Class B Class B airspace is defined around key airport traffic areas, usually airspace surrounding the busiest airports in the U.S. according to the number of IFR operations and passengers served. The exact shape of the airspace varies from one Class B area to another, but in most cases it has the shape of an inverted wedding cake, with a series of circular shelves of airspace of several thousand feet in thickness centered on a specific airport. Each shelf is larger than the one beneath it. Class B airspace normally begins at the surface in the immediate area of the airport, and successive shelves of greater and greater radius begin at higher and higher altitudes at greater distances from the airport. Many Class B airspaces diverge from this model to accommodate traffic patterns or local topological or other features. The upper limit of Class B airspace is normally 10,000 feet MSL. All aircraft entering Class B airspace must obtain ATC clearance prior to entry and must be prepared for denial of clearance. Aircraft must be equipped with a two-way radio for communications with ATC and an operating mode C transponder. Furthermore, aircraft overflying the upper limit of any Class B airspace must have an operating mode C transponder. Visual flight rules: flights may proceed under their own navigation after obtaining clearance but must obey any explicit instructions given by ATC. Some Class B airspaces include special transition routes for VFR flight that require communication with ATC but may not require an explicit clearance. Other Class B airspaces include VFR corridors through which VFR flights may pass without clearance. VFR flights operating in Class B airspace must have 3 miles of visibility and must remain clear of clouds. Class B airspace has the most stringent rules of all the airspaces in the United States. Class B has strict rules on pilot certification. Pilots operating in Class B airspace must have a private pilot's certificate, or have met the requirement of CFR 61.95. These are often interpreted to mean have an instructor's endorsement for having been properly trained in that specific Class B space. However, it does not apply to student pilots seeking sport or recreational certificates. Some Class B airports prohibit student pilots from taking off and landing there and are listed in the AIM Section 3-2-3, B, 2. In addition to this, some Class B airspaces prohibit special VFR flights. Certain Class B airports have a Mode C veil, which encompasses airspace within 30 nautical miles of the airport. Aircraft operating within the Mode C veil must have an operating Mode C transponder MSL, unless the aircraft is certified without an engine-driven electrical system and it operates outside the Class B and below the ceiling of the Class B and below 10,000 feet MSL. Class C Class C space is structured in much the same way as Class B airspace, but on a smaller scale. Class C airspace is defined around airports of moderate importance that have an operational control tower and is in effect only during the hours of tower operation at the primary airport. The vertical boundary is usually 4,000 feet above the airport surface. The core surface area has a radius of 5 nautical miles, and goes from the surface to the ceiling of the Class C airspace. The upper shelf area has a radius of 10 nautical miles, and extends from as low as 1,200 feet up to the ceiling of the airspace. A procedural outer area has a radius of 20 nautical miles. All aircraft entering Class C airspace must establish radio communication with ATC prior to entry. The aircraft must be equipped with a two-way radio and an operating Mode C radar transponder. Furthermore, aircraft overflying above the upper limit of Class C airspace upward to 10,000 feet MSL must have an operating Mode C transponder. VFR flights in Class C airspace must have 3 miles of visibility, and fly an altitude at least 500 feet below, 1,000 feet above, and 2,000 feet laterally from clouds. There is no specific pilot certification required. Aircraft speeds must be below 200 knots at or below 2,500 feet above the ground, and within 4 nautical miles of the Class C airport. Class D Class D airspace is generally cylindrical in form and normally extends from the surface to 2,500 feet above the ground. The outer radius of the airspace is variable, but is generally 4 nautical miles. Airspace within the given radius, but in surrounding Class C or Class B airspace, is excluded. Class D airspace reverts to Class E or G during hours when the tower is closed, or under other special conditions. Two-way communication with ATC must be established before entering Class D airspace, but no transponder is required. VFR cloud clearance and visibility requirements are the same as Class C. Class E controlled airspace which is neither Class A, B, C nor D. In most areas of the United States, Class E airspace extends from 1,200 feet AGL up to but not including 18,000 feet MSL, the lower limit of Class A airspace. There are areas where Class E airspace begins at either the surface or 700 AGL. These areas are used to transition between the terminal and en route environments. These areas are designated on sectional charts. Most airspace in the United States is Class E. The airspace above floor 600 is also Class E. No ATC clearance or radio communication is required for VFR flight in Class E airspace. VFR visibility and cloud clearance requirements are the same as for Class C and D airspaces when below 10,000 feet MSL. Above 10,000 feet MSL, the visibility requirement is extended to 5 miles and the cloud clearance requirement is extended to 1,000 feet below clouds, 1,000 feet above, and 1 mile laterally. Class F Class F is not used in the United States. In Canada, Class F is the equivalent of U.S. special use airspace including restricted and alert areas, while ICAO defines it as a hybrid of Class E and Class G, in which ATC separation guidance is available but not required for IFR operation. Class G Class G airspace includes all airspace below floor 600, not otherwise classified as controlled. There are no entry or clearance requirements for Class G airspace, even for IFR operations. Class G airspace is typically the airspace very near the ground, beneath Class E airspace and between Class BD cylinders around towered airstrips. Radio communication is not required in Class G airspace, even for IFR operations. Class G is completely uncontrolled. VFR visibility requirements in Class G airspace are 1 mile by day, and 3 miles by night, for altitudes below 10,000 feet MSL but above 1,200 feet AGL. Beginning at 10,000 feet MSL, 5 miles of visibility are required, day and night. Cloud clearance requirements are to maintain an altitude that is 500 feet below, 1,000 feet above, 2,000 feet horizontal. At or above 10,000 feet MSL, they are 1,000 feet below, 1,000 feet above, and 1 mile laterally. By day at 1,200 feet AGL and below, aircraft must remain clear of clouds, and there is no minimum lateral distance. It should be noted that there are certain exceptions where Class G extends above 1,200 feet AGL. This is usually either over mountainous terrain, or over very sparsely populated areas. Special use airspace. Some airspace categories have no correlation with ICAO airspace classes but are nevertheless important in United States airspace. The airspace class in which special use airspace is found still controls the requirements and procedures for flying into through it. Alert areas Alert areas are depicted on aeronautical charts to inform non-participating pilots of areas that may contain a high volume of pilot training or an unusual type of aerial activity. Pilots should be particularly alert when flying in these areas. All activity within an alert area must be conducted in accordance with CFRs, without waiver, and pilots of participating aircraft as well as pilots transiting the area must be equally responsible for collision avoidance. Alert areas contain special hazards that pilots must take into consideration when entering the areas. Warning areas A warning area is airspace of defined dimensions, extending from 3 nautical miles outward from the coast of the U.S., that contains activity that may be hazardous to non-participating aircraft. The purpose of such warning areas is to warn non-participating pilots of the potential danger. A warning area may be located over domestic or international waters or both. Restricted airspace Entry into restricted areas is prohibited under certain conditions without a special clearance obtained from the controlling agency obtained directly or via ATC. Examples of restricted areas include test firing ranges and other military areas with special hazards or containing sensitive zones. Prohibited airspace Entry into prohibited areas is forbidden under all circumstances, except for an emergency. Prohibited areas exist over a handful of extremely sensitive locations, such as the White House. Military operation area Military operation areas are areas in which military activities are regularly conducted. No clearance is required to enter MOAs, but pilots should verify with ATC or flight service station that no hazardous activity is underway before entering an MOA. In the United States, civilian and military pilots have equal rights to MOA airspace, and both have equal responsibility to see and avoid other air traffic. MOAs serve as a warning, since military aircraft often fly at high speeds and are intentionally difficult to see. Controlled firing areas areas in which activities could be hazardous to aircraft and distinguished from other special use airspace in that its activities are suspended immediately when an aircraft might be approaching the area. As a result, these areas do not appear on aeronautical charts. National security areas National security areas consist of airspace of defined vertical and lateral dimensions established at locations where there is a requirement for increased security and safety of ground facilities. Pilots are requested to voluntarily avoid flying through the depicted NSA. When it is necessary to provide a greater level of security and safety, Flight in NSAs may be temporarily prohibited by regulation under the provisions of 14 CFR Section 99.7. Regulatory prohibitions will be issued by System Operations Airspace and AIM Office, Airspace and Rules, and disseminated via NOTAM. Inquiries about NSAs should be directed to Airspace and Rules. Other airspace areas. These areas include Airport Advisory Information Services, Military Training Routes, Temporary Flight Restrictions, Parachute Jump Aircraft Operations, Published VFR Routes, Terminal Radar Service Area, National Security Areas. Terminal Radar Service Area Terminal Radar Service Area, or TRSA, is general controlled airspace wherein ATC provides radar vectoring, sequencing, and separation on a full-time basis for all IFR and participating VFR aircraft. Service provided at a TRSA is called Stage 3 service. TRSAs are depicted on VFR aeronautical charts. Pilot participation is urged but is not mandatory. They are designated in high-volume traffic areas where radar services are available but not otherwise designated as Class B or C airspace, such as the Palm Springs Valley in Southern California where high mountainous terrain channels air traffic into the same busy space. TRSAs can sometimes be found around Class D airports as well, such as East Texas Regional Airport in Longview, Texas, Chicago Rockford International Airport in Rockford, Illinois, and Kalamazoo Battle Creek International Airport in Kalamazoo, MI. When VFR, pilots need not contact TRACON prior to entry or while in any TRSA, however it is recommended they do so. There are no specific equipment requirements to operate VFR in a TRSA. If pilots ask for and receive radar services from TRACON, they must comply with heading and altitudes assigned or cancel the service. Temporary flight restriction Temporary flight restrictions are designated by NOTAM and are used to clear the airspace in special circumstances that could be hazardous to aircraft not participating in the event for which the TFR was issued. Situations in which TFRs are typically used include forest fires and other natural disasters, air shows, some instances of criminal activity, extensions of restricted airspace to allow expansion of military training operations, and during movement of the President and certain other high-level government officials. VFR chart notation. Specific conventions are used to indicate airspace boundaries on VFR sectional and terminal area charts for the United States. Class A Class A airspace is not shown on VFR charts, since it is assumed to extend from floor 180 to floor 600 everywhere. Class B Class B airspace is delimited by a heavy cyan border. Each distinct segment of Class B airspace contains figures indicating the upper and lower altitude limits of that segment in units of 100 feet, shown as a fraction. For example, 100/40 indicates a ceiling of 10,000 feet MSL and a floor of 4,000 feet MSL. In some areas each segment may also be assigned a letter for identification during communication with ATC. In many cases the boundaries of Class B airspace segments are coincident with specific radials from a specific VOA station or with specific distances from such a station. These are normally marked on the chart. In other cases, the boundaries may follow natural topological features or may be defined in other ways, which may or may not be explicitly indicated on the chart. Class C Class C airspace is delimited by a heavy magenta border. Each distinct segment of Class C airspace contains figures indicating the upper and lower altitude limits of that segment in units of 100 feet, shown as a fraction. For example, 100/40 indicates a ceiling of 10,000 feet MSL and a floor of 4,000 feet MSL. In many cases the boundaries of Class C airspace segments are coincident with specific radials from a specific VOA station or with specific distances from such a station. These are normally marked on the chart. In other cases, the boundaries may follow natural topological features or may be defined in other ways, which may or may not be explicitly indicated on the chart. Class D Class D airspace is delimited by a thin, dashed blue line, generally in the form of a circle centered on an airport. A number enclosed in a box surrounded by a similar dashed line and usually within the Class D area gives the upper limit of the airspace in hundreds of feet. A minus ceiling value indicates surface up to but not including that value. Class E Class E airspace is delimited in different ways depending on its lower altitude limit. Airspace in this class that begins at the default altitude of 14,500 feet MSL is not delimited. Class E airspace that begins at 1,200 feet AGL is delimited by a broad, shaded cyan border. Class E airspace that begins at 700 feet AGL is delimited by a broad, shaded magenta border. Airspace in Class E that begins at the surface is delimited by a thin, dashed magenta line. In many cases, the expanse of airspace that is Class E beginning at 1,200 feet AGL is so large that only the areas that differ are marked on the chart. Thus, one may see only external borders within the chart, with the 1,200-foot region extending off the chart. When Class E airspace begins at altitudes other than 1,200 feet AGL, 700 feet AGL, or 14,500 feet MSL, a delimiting border resembling links in a chain in dark cyan separates the areas, and specific altitudes are marked within or near them. References: Glider Handbook, pages 10-17, FAA Order JO 7110.65U, defines Class F airspace only within Canada. Federal Aviation Administration. Instrument Flying Handbook. FAA, FAAH 8083-15A, 2012. Federal Aviation Administration. Aeronautical Information Manual. FAA, April 3, 2014. Aircraft Owners and Pilots Association. Airspace Definitions. AOPA, SAO 2-9/05, September, 2005. National Archives and Records Administration. Electronic Code of Federal Regulations, December 13, 2007, 14 CFR 91.126 through 14 CFR 91.135. This article incorporates public domain material from the United States Government Document Instrument Flying Handbook.